Angle of intersection of two curves. The angle of intersection of two curves defined to be the angle between the tangent to the curves at their point of intersection. Let C1 and C2 be two curves having equations y is equals to f of x and y is equal to g of x respectively. X-axis, y-axis, this is C1 is the curve having the equation y is equals to f of x, and C2 is another curve having equation y is equals to g of x. Let PT1 and PT2 be the tangent to the curves C1 and C2 at their point of contact. PT1 is the tangent to the curve C1 at the point of contact P, and PT2 be the another curve. PT2 is the tangent to another curve C2 at their point of contact P. So let PT1 and PT2 be their tangents to the two curves at their point of contact. Let theta be the angle between these two tangents. Let theta be the angle between these two tangents. And theta 1 and theta 2 are the angle made by the tangents with the positive direction of x-axis in anti-clockwise sense. Theta 1 and theta 2 be the angle made by these tangents. PT1 make an angle theta 1 with the x-axis, and PT2 make an angle theta 2 with the x-axis in the anti-clockwise sense. Then M1 is nothing but slope of the tangent. We know very well slope of the tangent is nothing but slope of the line making an angle theta 1 with the positive direction of x-axis is nothing but tan theta 1. So M1 is tan theta 1. The same time slope of the tangent to the curve at the point at their point of contact is dy by dx. Therefore we will have M1 is equals to tan theta 1, which is nothing but dy by dx of the curve C1 at the point of contact. Similarly, M2 is nothing but slope of the second line. Slope of the second line is tan theta 2, since the line is making an angle theta 2 with the x-axis, and this line PT2 is again tangent to the curve C2. Therefore the slope of tangent is nothing but differentiation dy by dx of the curve C2 at their point of contact. Therefore angle between two curves theta having M1 and M2 as their slopes of tangents at their point of contact is given by the formula tan theta is equals to M1 minus M2 by 1 plus M1 M2. If the angle of intersection of two curves is right angles, then the two curves are called orthogonal curves. Once again I repeat this formula. The angle between two curves theta having M1 and M2 as their slopes of tangents at their point of contact is given by tan theta is equals to M1 minus M2 by 1 plus M1 M2. Now, if the angle of intersection of two curves is right angles, the two curves are called orthogonal curves. If the curves are orthogonal, we will have the angle between them is 90 degrees, that is theta is equals to pi by 2, which implies 1 plus M1 M2 is equal to 0, because when theta is pi by 2, tan pi by 2 is infinity, so obviously denominator should become 0. So 1 plus M1 M2 is equal to 0, which implies M1 M2 is equals to minus 1, which is the condition for the two lines to be perpendicular. Now example. Find the angle between the curves xy is equals to 2 and x squared plus 4y is equal to 0. Solution. Let us find the point of intersection of xy is equals to 2 and x squared plus 4y is equal to 0. So let us, two curves are given for us, xy is equals to 2 and x squared plus 4y is equal to 0. To get the angle between these two curves, first we need their slopes. So slopes at their point of contact. So we need the point of contact. So solving these two equations. From this equation, x is equals to 2 by y. Substituting x is equal to 2 by y in the second equation. So we'll get it as 2 by y whole squared plus 4y is equal to 0. Squaring this, 2 squared is 4 by y squared plus 4y is equal to 0. Taking LCM, 4 by y squared, y squared into y cube. So 4 plus 4y cube is equal to 0, which implies y cube is equals to minus 1. That is, y is equals to minus 1. When y is equals to minus 1, substituting in this, x is equals to 2 by minus 1 minus 2. So the point of intersection of two curves is P minus 2 comma minus 1. Now xy is equals to 2. From this, y is equals to 2 by x. Differentiating this one, dy by dx is 2 is constant. Differentiation of 1 by x is minus 1 by x squared. So dy by dx for the first curve is minus 2 by x squared, and the slope of the tangent is nothing but the differentiation at the point of contact. So the point of contact is minus 2 comma minus 1. Substituting in the x place as minus 2, our m1 is minus 2 by minus 2 whole squared, which is minus 2 by 4, which is equals to minus half. So m1 is equals to minus half. Now second curve, x squared plus 4y is equal to 0. Y is equals to, from this, minus x squared by 4. Again differentiating this curve, 4 is constant, 1 by 4 outside. Differentiation of minus x squared is minus 2x. So dy by dx is nothing but minus 2x by 4. Cancelling this, we'll get minus x by 2. And m2 is the slope of the tangent at that point of contact. Point of contact is minus 2 comma minus 1. Substituting minus 2 in the x place, we will get minus of minus 2 by 2, which is 1. So our m2 value is 1. Let theta be the angle between the curves. Then our formula tan theta is equals to modulus of m1 minus m2 by 1 plus m1 m2. m1 is minus half and m2 is 1. Substituting these values, minus half minus 1 by 1 plus minus half into 1. Simplifying, 2 is the LCM. So minus 1, 2 ones are 2, minus 3 by 2. 1 plus half into minus half is minus half. 1 minus half is half. This is minus half. So we'll get angle S. This is 3. So tan theta is equal to 3. That is, theta is equals to tan inverse of 3.